हेलो स्टूडेंट्स, सो वी आर गोइंग टू टेक अप टुडे चैप्टर मेटलर्जी और आज हम इसका करने जा रहे हैं क्विक रिवीजन. ओके, इन दिस चैप्टर चिल्ड्रन you are getting definitions of mineral, right, and ore. So what do you understand by mineral? So mineral is any naturally occurring substance, okay, naturally occurring substance which is associated with earthly impurities. So this is a substance which has got earthly impurities and we call this as mineral. Okay. Now these substances are basically what these substances are compounds of metal. Okay. Now what are ores? Ores are naturally occurring minerals. Okay, so the definition says ores are naturally occurring minerals from which the metal is extracted profitably. Okay, so this you have to remember. So once again I am repeating mineral. What is mineral? The definition says the naturally occurring compounds of metal or substances which are associated with earthly impurities. They are known as minerals. And the ores are naturally occurring substances or minerals from which the metal is extracted profitably or economically. Okay, so this is part 1. Right, the second part you have in your course is the important ores of aluminium, iron and zinc. So let's take up the important ores of aluminium, right? So if we talk about aluminium, the three important ores are, first of all is bauxite, okay, and its formula is Al2O3 dot twice H2O. We also call this as hydrated aluminum oxide or bauxite, right? Then we have corundum. Corundum is anhydrous aluminum oxide, that means without water. Third is cryolite, right? The formula is Na3AlF6. So these are the three important ores. Question may be asked, mention or write two important ores of aluminum, or they may say that bauxite and corundum are important ores of dash. Or the multiple choice question can be, they can mention 3-4 ores and they can ask you which one of the following is an ore of aluminum. Okay, so you have to understand the concept better, right? Next we talk about zinc. So for zinc we have zinc blend. The formula is zinc sulfide. Then we have zinc tide. Formula is zinc oxide. We have got calamine. Children, calamine lotion you will find as a medicated lotion for skin. So the formula is zinc carbonate. Okay. Then third category we have important ores of iron. So in iron we have first ore most important as hematite ore. This hematite ore is ferric oxide. Then we have magnetite ore. Magnetite ore is combination of ferrous and ferric oxide. So we write this as Fe3O4, right? Then we have got sphatic iron. Okay, it is also known as siderite. We call this as iron carbonate. Okay, so these are again the important ores. So what you have to remember is that out of these three, the question may be asked, you have to mention the common ores. Okay, so you have to learn the ores along with their name and formula. Remember, if you want to score full marks, then you need to remember both. That means formula as well as the name. If you just write formula, then you will not get any mark. Okay, is this clear? Now we next come to the extraction of aluminium. Okay, so let's once again repeat the important ores. We have extraction of aluminium ore from bauxite ore. So what is the formula? It is Al2O3 dot twice H2O. This is the important ore of aluminium, right? This ore of aluminium is associated with impurities like sand, impurities of iron. Okay. So we have in our course purification through bare species, right? So what we do, let's take up immediately. We first take pulverized ore. What is pulverized ore? The ore which is crushed into fine powder, washed with water, dried in. That ore is known as pulverized. This pulverized ore is passed through magnetic separator. So in magnetic separator, what is removed? Iron impurities are removed. Okay. And what do you get? You get bauxite ore, and what is not removed? The impurities like sand. So they remain with the bauxite. Right. Now we perform Bayer's process. In Bayer's process, we actually purify the impure alumina. We call this as impure alumina. So this impure alumina is purified to pure alumina, right? The name is Bayer's process. This Bayer's process has got three legs, that means three parts. First is digestion step, second is seeding step, third is ignition. We'll take up one by one. After pure alumina, we follow Hall Heroult's process, right? Through this process of electrolytic reduction, we get aluminium metal. Then this aluminium metal is purified right through Hoops process and we get. Now in your course you have up till here. आपके course में सिर्फ यहाँ. Okay. So let's take up in detail one by one. Right. So first is Bayer's process. So children, what is the aim of this process? It converts impure alumina to pure alumina. Okay. Now, it is also known as, what is another name? The another name is concentration of. Okay. Which chemical is used? It is conducted through sodium hydroxide concentrated solution. So, step 1 is also known as digestion, where alumina, right? The concentrated alumina is treated with sodium hydroxide concentrated solution at temperature 150 to 200 degrees centigrade in a digester, right? It's like pressure cooker or autoclave, right? Under pressure for at least 1 to 2 hours. Okay, right? And what do you get? All the aluminium which is present in the bauxite ore combines with sodium and forms soluble sodium alumate, right? Water is formed and impurities are left behind. Okay, this soluble means if you filter, impurities will be on the filter paper, right? And you will get sodium aluminate in soluble form. Right, the process is known as digestion. So children, ये reaction आपको अच्छे से याद हो गया. इसको देख लीजिए, इसको balance कर लीजिए. 2 NaAlO2 and 3 water. What you have to remember is balanced equation. ठीक है. Balance के साथ again fetching marks. Concentrated is very very important. Concentrated word. Okay. Right. Now after this we talk about step 2. Okay, so step 2 is known as seeding. What we do is we create crystals of, we create seeds, not crystals, seeds of aluminum hydroxide. So what do? We take this soluble sodium aluminate, right? Dilute this with water, put it in a precipitator, temperature 50 to 60 degrees centigrade. Okay. So in the precipitator, when this is churned or mixed well with freshly prepared aluminium hydroxide. Okay. Now what will happen? Entire aluminium with water is converted into aluminium hydroxide precipitate. This precipitate is of white color, and what do you get? You get sodium hydroxide. So sodium hydroxide is regenerated, balance the reaction. Okay, so what do you get? White color sodium, sorry, you get aluminium hydroxide, white color precipitate, and you get sodium hydroxide. This is regenerated and is used for digestion. So this is very important. Name a chemical which is regenerated. It is sodium hydroxide. After second, this is known as heating step because all the AlO2 aluminium in here is converted into aluminium hydroxide with help of freshly prepared aluminium hydroxide. Okay, so this is known as heating. After this, we have got step 3. Step 3 is ignition, where the entire aluminium hydroxide, right, is heated at 1100 degrees centigrade. Okay, so when it is heated at 1100 degrees centigrade, this white precipitate is converted into pure alumina Al2O3 and water is formed. Okay, so we take two molecules of aluminium hydroxide and we get pure alumina with free water. Is this clear, children? Right? Now, after this, we move on to the process electrolytic reduction. So, what is the product? The product is Al2O3. So, what do? We perform reduction. Right? Now, when we perform reduction के लिए what we need? Either we can take carbon, hydrogen, carbon monoxide. These are, the common methods used for reduction. But aluminium is an active metal, so these are not effective. Hence, what do? We go for electrolytic reduction. So, with help of electrolysis, we remove. With help of current, we remove or we break the bond between aluminium and oxygen. So, we call this as electrolytic reduction. Now, how do we perform electrolytic reduction? We perform electrolytic reduction in a vessel. This vessel is actually made up of iron, right? So it's an iron vessel, okay, and it is lined with, let's take another color, okay, so it is lined with, I have taken red color so that you can see, lined with gas carbon, right? So this is gas carbon and therefore it acts as, okay, so it acts as cathode. Cathode has got, right, a small, which shows with negative end. It's this and this is the sign for anode, a bigger line, right, positive charge. Now this anode is actually made up of, there are multiple anodes, right? These are multiple carbon rods. Why there are multiple carbon rods? In order to increase the surface area for reaction to speed up the reaction. So these are the carbon, okay? And these carbon rods are attached with copper clamp, okay? So this is how it is linked, okay? Right? Now, the surface of this vessel is sprinkled with coke, right? And the electrolyte over here is 1 part cryolite. I'll change color because it's a dark color. Okay. So there is 1 part of cryolite. Cryolite is fused in state. That means it is molten in state. It acts as solvent. Okay. Then this is 3 parts of cryolite. This is first ingredient. The second is 1 part alumina, right? And then you have 1 part fluoride. So the electrolyte is combination of 3 parts of cryolite, 1 part of alumina, and 1 part of calcium chloride. Now this cryolite function is to dissolve alumina 1, right? Second, cryolite and phosphor, they together, they decrease the reaction temperature from 1800 900 degrees centigrade. Okay. Also, calcium fluoride increases the mobility. Mobility increases the mobility of ions in the vessel. Right? So this is the electrolyte. Reaction temperature is 950 degrees centigrade, and over here there is a control lamp. Okay, the function of control lamp is to confirm whether the reaction is taking place or it has stopped. Okay, so if it glows, that means the reaction is taking place. It has stopped, that means the reaction has been complete. Now these carbon rods, right, which acts as a node, they are periodically placed. Okay, now let's see what is the reaction taking place. So we have NaClF6. How many parts? Three parts. So this breaks or ionizes and iron plus aluminium iron plus 6 chloride ions, right? Then you have got fluorspar. Fluorspar also breaks into calcium ions and chloride ions. Okay, and pure alumina breaks into aluminium ions and oxide ions, right? So these many ions are present in the electrolyte solution, right? Now what happens? According to Arrhenius electrochemical series and preferential discharge, what will happen if we talk about aluminium ions, sodium ions, and calcium ions? So, out of these positive charge, only aluminium ions will be discharged or they will react first. The reason is they lie low in the electrochemical series. Okay. So, what will happen at and now let's take up the reaction. The reaction will first take up at anode. Okay, so let's talk about anode. At anode, there are oxide ions and there are chloride. So again, oxide ions are lying low in the series. So therefore, oxide ions will charge first. So at anode, oxide ions will convert into oxygen atom, nascent atom, by releasing. And these electrons will come and combine with that cathode. Okay, will combine with aluminium ions and will form aluminium metal. Right? Now this aluminium metal has got boiling point. Pure aluminium has got boiling point around 666, right? And the vessel temperature is how much? 950 centigrade. So in place of solid, this will be in liquid form and hence it will start flowing down. So there is a tap over here, and from the tap, aluminium metal will be opened. Is this clear? Now if we see the reaction, so the reaction will be Al2O3, right, breaking into two aluminium, three oxide ions at cathode, two aluminium ions plus 6 electrons will form two aluminium metal, right? And at node, you will get three oxide, three. So three oxide ions will about 6 electrons will form three nascent oxygen, and this is going to form how much? We can write 3 by 2 O2. Okay, so this is what we are going to get. Okay, so you get oxygen gas at anode and you will get at cathode aluminium metal. Okay, now these electrons they cancel out. Okay, so if you see, this is what you are going to get, right? Now, what do you get? You get oxygen here. You get oxygen gas at anode. Now, when this oxygen gas comes over here, it is sprinkled with coke. So, oxygen will combine with coke to form carbon dioxide, or some of the carbon will combine with oxygen to form carbon monoxide. So, you will get what? carbon monoxide, carbon dioxide, right? And this carbon dioxide formed is going to act as insulator. Okay, so that will maintain this temperature 950 degrees centigrade. Okay, why anode is periodically replaced? The reason is the carbon rod over here also will participate chemically with oxygen gas and will convert or will form carbon dioxide. So gradually, this will reduce in size. So in order to have a speed up reaction, these are periodically replaced. Now, why there are multiple anodes? In order to increase the surface area so that there is a fast chemical reaction. Is this clear? So, children, this is the aluminium extraction. आपको बस इतना ही करना है, आपके कोर्स में सिर्फ इतना ही है. Right after this, you have got alloys. Okay. So the last topic is alloys. What are alloys? Alloys are actually combination of more than two or more than two metals. Right? Two or more than two metals combination is known as alloy. The reason is to enhance or change the properties of the combination. Like for example, if gold is there, pure gold is very soft, you cannot wear it as ornament, right? So it is mixed with copper, mixed with silver, and then it is converted into ornamental gold, which becomes hard and can be worn. Okay, so this is the use of alloy, right? Another thing, if this alloy has got mercury as one of the components, then it is known as amalgam. Okay, now you have in your course the uses and alloys of aluminium. Okay, so the important alloys of aluminium are, one is dura-alumin. Okay, second is magnesium. Children, inka composition is not in your course, right? So this is L-nico. Okay, so dura-alumin has got aluminium along with this magnesium, manganese and copper. Magnesium has got aluminium and magnesium. L-nico has got aluminium, nickel, cobalt and iron, right? Now, aluminium itself is a white and a light metal. Okay, so if we want to make an aircraft, because we can't have it of iron, iron is hard, heavy. Okay, but iron is hard. Aluminium is light, but it doesn't have the tensile strength, it is not that hard. So what do? We convert it into dura-alumin or magnesium by adding the metals. Is this clear? So the property of dura-alumin is it is light, right? It is strong, right? Stronger than aluminium, and because of its lightweight, it is used for making the aircrafts, right? Tools, ships. Then we talk about magnesium. Magnesium is also strong, right? It is anti-corrosive, hence it is used for making tools, the balances, right? Then L-nico is used for making magnets because it has got iron, right? It is light and shiny because of aluminium, and it is non-corrosive again because of aluminium. So all these properties are important. So children, you have to take up these properly. बहुत अच्छे से करिएगा. आपको properties करनी है, इनके uses करने हैं. इनका composition आपको नहीं, पर आपको components पता. Exact composition नहीं, but components. This clear? So this is all in the chapter 6 metallurgy. अच्छे से कीजिएगा. Prepare well. All the best. And for detailed videos, children, I am attaching the links of my previous videos जो बहुत detail में है. So you can take this from the description box और आप इसको देख. Okay, all the best. Thank you.